Good morning. Let us start. So, we will today start a new course called Metrology in Chemistry. And I will first give you an introduction, what it is, and then how we work and so on. And then, of course, we immediately start with the first part of the course materials. I guess you all received a message from me yesterday, right? Yeah, with some information. Okay, so good. Yeah. Then obviously this mail sending system seems to be working. So this course attempts to give you a basic knowledge of metrology, or let's call it measurement science aspects of chemical analysis. So we will try to give here these, let's say, very basics. Then I will try to teach you how to see and understand the specific problems that there are with chemical analysis or chemical measurements, as opposed to physical measurements, which are oftentimes simpler. Also, we will look at some basic mathematical apparatus. This course can, in principle, be lectured at very different mathematical depth. It can be made very, very mathematically. But we here typically try to keep the mathematics rather simple than too sophisticated. Then, of course, there will be practical examples and good morning. And very importantly, from this course, you also will get some general analytical chemistry knowledge. So in a way, this course could be called Analytical Chemistry Zero. Why zero? Because it gives some kind of underlying foundation on which you can build any analytical methods based on any techniques. So our course is in many ways like technique neutral. In some cases we do, but most of the time, the principles, the approaches that I'm going to teach here can be applied with any technique, be it some atomic spectrometry, gas chromatography, titration, whatever. So again, yeah, it expects that you already know these techniques, which you have learned from the previous analytical chemistry courses. Those of you in each program you've learned in your previous study level and also last semester from Professor Koit in the practical chemical analysis. And now we can look at this foundation and we will here use the different techniques that you have learned as examples. So the approaches, they are universal, but the different techniques and methods will come in as examples. Now, we mostly try to take as pragmatic and practical approach as possible, which is directly applicable in a real-life practical laboratory. Again, as I said, this course can be made very, very sophisticated and scientific, but this is not what we do. This also means that every now and then we simplify. So there are many things in this course that I'm going to present you in simplified way, so that it is practically useful, practically applicable, but not necessarily fundamentally 100% rigorous. I'm going to explain those situations as we go, and I will warn you. In some cases, what you will hear from me might not be endorsed by all metrology people or by all analytical chemistry people. why I'm teaching you the way I am is exactly for this, so that the most important thing is that you can use it in your practical work as much as possible, as opposed to going to full rigor and highly sophisticated method. And here, what I already said, we do not go mathematically very deep. Actually, I would like to give you minimum mathematics. And why? We have done a lot of collaboration with different laboratories. And the experience very clearly shows the question is not the lack of mathematics knowledge. Sometimes in the labs, I see people who are much better in mathematics and statistics than I am. The key thing is rather all these things here. How do you get the necessary data? If you have some data, what do the data mean? That's actually turns out to be a very big thing. And then lots of people have lots of data. They use it somehow and pass it through very sophisticated mathematics, which sometimes leads to, if not nonsense, then not very useful outcome. Yeah. So that we will try to be rather simple than too sophisticated, but we will try to work in such a way that you will get very clear understanding what you are doing, even though you are doing maybe quite simply. Yeah. So that, yes, oftentimes quite simple mathematics is beautiful. Yeah. No problem. Yeah. So that oftentimes quite simple mathematics is fully sufficient. Any questions up to now, maybe? Let me just say, this will come later on also, but let me already now say, the more questions you ask in this course, the better it is. Do not wait. I will make sometimes pauses and ask whether you have questions, but you don't need to wait. If you are in the room, just raise your hand. If you are online, just start typing into chat. So if you participate online at any moment, just write your question into chat. I will see that there's a question in the chat, or somebody will shout at me from the room, and then I will make a pause at the suitable place, and I will take your question. It's important to ask questions immediately, because later on you might forget what it exactly was that you wanted to ask. And I'll explain later on when we come to the exam, but understanding is absolutely the most important thing here. So whenever you have some doubt whether you understood right, better ask. Okay. Yeah. Now, organization. Yeah. We will have two course times which will run throughout the semester on Tuesday and Wednesday, 10:15 in this room. Occasionally might happen that maybe I'm away from Tartu, maybe I'm ill, but not too ill. Yeah, then I can do the lecture online. I usually warn you beforehand. Yeah, so we will try to do in such a way that we will lose as few lecture times as possible. And also, in case you are ill or something happens with you, you can also participate online. Like we are right now running this whole thing in hybrid mode. I intend to do that throughout the semester, so that you also would not lose any lectures if possible. But also I plan to record all the lectures. And actually, what you already can have, all the lectures from the previous years already are recorded and available. So that actually, in principle, you can have all the lectures this week if you like, yeah, and look at what they were last year. But of course, I change a little bit every year so that it's not exactly the same what I explained last year, but it will not be very different. And we will have one additional lecture time on Friday, and this will happen from week 34. I wrote here April 25. I hope this is more or less correct. So starting from that date, I think five lecture times, 5 additional lecture times will also be on Friday. Otherwise, we will not really manage to pass all the material. And why lectures take quite a bit of time is that I very much like to initiate discussion here, and occasionally over the years it has worked well. So students start discussing, and this is the most valuable part of this course. Also, your questions and my answers are typically more useful and valuable things than lecturing. This is why I'm encouraging the questions all the time. Now, the forms of work are here: lectures and seminars and practicals. Oftentimes they are lecture, seminar, practical, which means that first I lecture something, then we will discuss, and then you take your computers and we calculate something. So this course also has practical sessions, but they are not in the lab. They are in this same room with your PCs. All you need is some spreadsheet software, which typically is Microsoft Excel. We do all the calculation in that software. And as I said in the previous slides, I try to teach you also some of the data analysis and the mathematical approaches. And in order to do that, we need to do calculations. You have to do. And you have the nice way of practicing those things with homeworks. There are a range of homeworks in the Moodle, which in principle you can start solving this evening if you wish. But of course, it's probably more fruitful if you wait until we do the respective thing here in the class. So for all homeworks, there is something before the homework that we do here in class, something similar, and then you can go to the homework. I will, when we come to that, it will not happen during the first lectures, but when we come to that, I will specifically explain, okay, this exercise now was the basis for this homework, and now you can go and do the homework. Sometimes still it can happen that lecture will not take place if I'm away somewhere and occupied at exactly the same time, then we simply have to cancel the lecture. I also hope that I will be able to tell that to you beforehand so that you don't come here without the lecture. And also all these times that are in the study information system, they can be consumed for any of these work types, for lecture, seminar, or practical class. And also, having said that, please ask as many questions as possible. I also ask sometimes questions. Then I hope to hear your answers. And sometimes I make polls with this Moodle system so that actually, even if you are in the room here, it might still be useful to also go to Moodle like Elvin has done now, so that you can participate in poll. Or sometimes I will simply ask you to raise the hand, so whichever way it goes. It's often quite funny, actually. Sometimes I ask, which of these two options is true? Only one can be true. Sometimes it's almost like 50-50. Some people raise hand on option 1 and the other on option 2, and then we discuss why the one or the other is correct, and so on. Next thing, information exchange has never been easier than in the 21st century. So this slide is almost like unnecessary. Whatever I say here, I assume that all of you have heard. occasionally I duplicate some important organizational information with email, but not always. And since everything is recorded and your friends are here in the room, I think it's obvious that if you were not present, you watch the recording to learn what was said. Was there any organizational information? So that I assume that if you cannot come to the class, you watch the recording as soon as you can, so that you can be up to date what was explained. Then obviously, please keep your email up to date. I think it's probably is up to date. If you received my message from yesterday, it's all fine. If you did not receive it for some reason, then you need to see whether you were not registered to the course or what. And also in Moodle, there's a forum which is called, let me see, who is it? Questions, answers, yeah. There's a questions, answers forum in Moodle where you can post any questions you have. If it comes at some point when you are at home working with these materials, you don't understand, you can immediately write to the forum. I will then either reply next lecture or will reply to the forum. Now, these practicals I already mentioned. Perhaps there is no point to explain all these problem types here. As time comes, you will see. Also, you have this practical program part, this file. We'll quickly show it. So this thing you have. We will not do necessarily exactly everything that is here, and not exactly in the same order as it is here, but more or less these are the things that we do. And as I said, when the time comes, I will explain when you should bring your computers with you. So that you don't need to have your PCs here every time, although it might perhaps be useful. But when I think that, okay, maybe next time we will reach a place where we can do calculations, then I will tell you that now, next time, please bring your laptops. There's anybody who does not have a laptop, come to me. We will then need to figure out some solution. And essentially any spreadsheet software is fine. This is something I already explained. For every problem that we solve here, problem type that we solve here, there's homework which you have to do. And as I said, we strongly recommend that you use your own laptops. But if some of you doesn't have, I will have to find some kind of solution. I would not like to go to computer class with this exercise. First of all, there are quite many of you. We will not fit in there. And almost always those exercises that when we solve some practical things here in the class, I also want to show slides. I want to explain, which is not, I cannot do that easily in the computer class. Also, in many of those cases, I need two screens. So I have slides on one screen and my own Excel on the other screen, which actually gives added value, which also I cannot really do in computer. So I very much hope that we can do also the practical exercises here. As you have no doubt noticed, there are also power sockets almost like under every seat, so that the power is also not an issue. Now, homework. Let me give some more information about that. It is in Moodle. You submit your results there. It's some text, and then there are some slots where you can type numbers or some phrases. You have unlimited number of attempts. And there's no penalty for mistakes, so you do not need to be afraid to try several times. If it's wrong, the system will tell you it's wrong. But eventually, all questions in all homeworks must be 100% correct. Very, very easy. You have to get all the homeworks correct 100%. Only then they are considered solved. And of course, you are allowed to discuss with each other, but please note this here, within reason. Discussing does not mean that you sit together at the PC and the other person tells you, okay, now click there, now write 57.2, okay, 57.2, now solve, yeah. So each of you has to solve homework yourself. It's not allowed that somebody will solve it for you. Of course, as you easily can understand, I don't have any way of checking. I cannot come to dormitory rooms and look who is sitting where and doing what. That's unthinkable. So I count that you are all honest people, yeah? and don't do any fraudulent actions. Yeah? If by the exam time there are unfinished homeworks, then your grade will decrease. Meaning, you are not really obliged to complete all the homeworks, but you will get lower grades from the exam. Very easy. For every unfinished homeworks, meaning homework less than 100% correct, your exam grade will fall by one unit. Yeah. So that, for example, here is, you had 2 unfinished homework by the time of the exam. Your exam answer was a B, and I will put you D into the study information. B, C, 2, all 2 points. So that although it's not required to complete all homework, but it's very much recommended, because otherwise you might get a very bad exam grade. And starting from some number of unfinished homeworks, it's impossible to get the positive grade, because even if you get A, you subtract so many that you will still get F. Yeah, so that you simply cannot pass. Moreover, please pay attention here. The exam also has calculations. I will come to that. I will explain how we do exam. So during the exam, you will get exercises which are similar to homework, which you then need to solve. Now, if you haven't done the homeworks, yeah, you haven't trained yourself, you might be also in difficulties. And there is right now no strict deadline for finishing the homework. It also depends to some extent how we will go here with our lectures. It's not easy to plan for this course when we finish some kind of topic. And the reason is that whenever somebody asks a question and initiates the discussion, I will go together with the discussion. Discussion can take a long time. Discussion is a long thing. If different people have different opinions and questions, then I will explain what is right, what is wrong. This all takes time, which cannot be planned, so that I cannot plan very well in advance when we reach at some point. But sometime, it probably will happen sometime in June, that I will close the Moodle homework thing so that you cannot submit your homeworks anymore. Then if something is unfinished, it remains unfinished. But you can be assured you will have far enough time to complete all the homework. So closing the Moodle system will not happen before maybe 3 weeks from the last practical session here in the class. So you will have several weeks to complete the homework. There is no rush that, today we did it in the class, tomorrow 5 o'clock Moodle will close, I will now have to run to home very quickly. That will not happen. You will have sufficient time, but you will have to be able to organize yourself. Don't leave to the last minute. And I very much recommend that whenever we do something in class, you immediately start with the respective homework. Some people collect all the homeworks to the end of May, and then they are in trouble because there are many of them, some of them not so easy. Yeah, they try, no right answers, then they get very nervous, then the nervousness does not help. Yeah, they get still wrong answers, then they are very upset, and things don't really go well. So try to work throughout the system. Course materials are available on Moodle. Perhaps I will quickly show what the Moodle looks like. No, it's actually a good idea that I would see it pretty much the same way as you see it in your Moodle. Okay, so the course materials start running like this, yeah, from here. You can see that actually already all the course materials are available, but don't download everything yet. The reason is that most of these course materials that you see here are still from the last year. And to most materials, I make changes every year. So most of them change a little bit, not so much, yeah, but a little bit. So that you can always, when you download any slides, check on the front page the date. Front page almost always has the date, and if the date is from 2025, then this is updated. If it's still 2024, it might change a little bit. The changes will not really be very big, but every year I find that I can improve here and there, and so some changes happen. Okay, then here are different links to different let's call it guides, occasionally also books. I will come to that in some minutes. And here are the homeworks. Yeah, so you can already find the homeworks. Here we have tests. We have intermediate tests. I'll explain in a moment. Oh yeah, and exam times I should actually hide that. Do that immediately. Exam times do not really. These exam time choices that you see here are still from last year, so that they are irrelevant to you. But I will put up new exam dates, and I will, or exam times, and I will explain what I mean by that in a few minutes. Oh, are not visible. Before I go back to the slides, any questions? Okay, yeah. I haven't really explained anything complicated. Yeah. Pretty understandable. Yeah, okay. Yeah. And all these recordings are under this big blue button. I think you know how to access. You can look. What concerns exam questions, these right now are also the last year's exam questions. I don't expect big changes. 95% they will be the same. But some changes I always introduce, and I will let you know when they are finalized. Typically, I finalize exam questions at the very end of the semester when it's clear what was explained and how was explained and so on. No? But if anybody is very anxious, already start learning for the exam, then you can do that this evening if you like, because as I said, most of it will remain. And yes, I don't bring printouts. This is perhaps not even needed now anymore. In the past, in the distant past, I brought also printouts of materials, but now everybody has these tablets and PCs and so on. Printouts are not so popular. Now, literature. What materials or what literature is available? Metrology in chemistry is a strange discipline in the sense that it's not yet as mature as I would say organic chemistry or physical chemistry, etc. And as of now, at least, I do not know of a single one textbook that I could recommend to you, which would have everything that we need in this. So there's no one universal textbook, and therefore I very much recommend to attend classes and look at lectures. But then the good thing is that there are a number of very good materials, and many of them are freely available on the web. They cover the majority of our topics, but not all. And some things we lecture here somewhat differently than what is written in those materials. So that, as I said, in any case, coming to the lecture is very much recommended. And now let me run briefly through these materials. They are all available on Moodle also, but for some of them there are also web links here. So first of all, there's a VIM. VIM is Vocabulaire International de Métrologie, International Vocabulary of Metrology, which is the terminology source. So this is our primary source of measurement terminology, although we do not always adhere. I again have to, I will explain later on, there are some special cases when we don't use the same terminology simply because chemistry lab people do not speak that way. Then this is possibly the best analytical chemistry terminology material that exists. It has been published by IUPAC. It's Compendium of Terminology in Analytical Chemistry, but in colloquial language, everybody calls it Orange Book because of its orange cover. This is not a free material, but in the UT network, you have free access because we have bought access. So if you go to this DOI, you can get the access to it. It's really, really good. I would say that it's even better than VIM, although not so well known. It's better in the sense that, first of all, it's oriented towards chemistry, while VIM is still oriented like towards everybody, or rather towards physics. You know? And secondly, it is very recent. See, it's from 2023, and some of the VIM's mistakes have been corrected. And it is good also that although we are here, like, let's say, metrology and chemistry lecture, MIC is the common abbreviation. But this Orange Book has all the analytical chemistry, all the techniques, all kinds of MS ionization sources, then atomic spectroscopy things, fluorescence, etc. So it's really, really good. It's massive. I don't remember how many pages, but it's many hundreds of pages. It's a very, very, very big thing. Yeah. So I can only praise it. Yeah, very, very useful. Then measurement uncertainty. Here we are largely guided by two materials. One is the EURACHEM uncertainty guide. Its third edition is from 2012, and new edition is right now being prepared, but it's not yet out. So that right now we will still be guided by that one. But it is well possible that maybe later this year or maybe next year there will be new edition, and there will be some changes also. In some cases, I will explain some of the changes. So this is very much the, let's say, the uncertainty Bible for chemists, or let's put it, one of two uncertainty Bibles for measurement uncertainty Bibles. And this is the other one. This is Nordtest Uncertainty Handbook. It's not as well known, not as widespread as the EURACHEM guide, but in practical laboratories, it actually is, in my opinion, even more useful. It presents a very pragmatic and, I would say, simple approach of evaluating measurement uncertainty, even for very sophisticated analytical measurements, which has, like, time has shown and experience has shown that these are very realistic uncertainty estimates that come out of this. Actually, those of you from the EACH program in the recent winter school, you already used the Nordtest approach. So the way you calculated uncertainty was that way. here in the class, in this course, we will go somewhat deeper than the very, like a very, very short and brief experience that you had in the winter. Here is another document from Nordtest. It's about laboratory quality control. I would say the main topic in this that is important for us are the control charts. Very, very useful things for keeping your laboratory methods under control. This is another one from EURACHEM, which is about validation. Method validation is an interesting topic because there are numerous, I would say close to 10 prominent guidelines. And if we take also less prominent guidelines, there are more than 10 that are available, which sometimes have somewhat conflicting recommendations, etc. We largely adhere to this EURACHEM validation guide in our course, the validation section, but not entirely. So it's not, we don't always adhere to it. And here is an interesting one. This comes from our group, actually. It's a tutorial review on validation, but it's not just validation. It's specifically about liquid chromatography mass spectrometry methods. And what is interesting here is that we took, this is now already 10 years old, but still fairly relevant. We took a number of guidelines and distilled some general recommendations out of those guidelines. So that this two-part tutorial review gives a fairly nice big overview how you should go about validating your LC-MS. Although it's written sort of for LC-MS, but it also is applicable to a large extent to any other technique. Let me check. Yes, I have it also. Yes, it's also in Moodle. Yeah, sure. Also available for you in Moodle. And those who go to, again, if I'm speaking about each student, those of you who go to Uppsala and then start working on some liquid chromatography mass spectrometry thing, then this might be very useful for you in your master thesis work also, not only in. And then there's another EURACHEM material which is about traceability. I will, when we come to that, then I will. And then we have an interesting, like, companion course, if I can call it that way. Some of you may know that we do those online courses of massive open online courses, or MOOCs. And one of them is measurement uncertainty in chemical analysis. Registration is right now open at this address. Participation is free of charge. It will run from March 25 to May 7. I very much recommend you to participate, but it's not mandatory in any way, but I recommend you to do that. Also, this, would I put it? There is a course code associated with that online course, so that if you participate, you will get one ECTS credit. Okay, one ECTS credit is not a lot, yeah, but on the other hand, the knowledge might be worth it. Why I especially recommend it? In the distant past, I did not recommend, but when I started recommending it, then in this our metrology and chemistry course, the exam answers and test answers to measurement uncertainty related questions became much, much better than they were in the past. So that participating in this course helps you with this our metrology and chemistry. If you don't register, then what I do recommend very much, what also actually gives you a lot of benefit, try all these self-tests. You see, there are a number of self-tests. Yeah, only 2 are visible, but actually all these sections, they have self-tests. for doing that, you can simply go to this address. You don't need to register or do anything at all. Yeah, you just go to this menu, go section by section, and try the self-test. It's very useful for preparing for the exams and tests of this particular course here. Yeah, so even if you don't register, I very much recommend that you do the self-test. You can even take this approach that whenever this some uncertainty topic has been covered in this class, then you go to online course and try the respective self-tests if you and all these materials are available without any registration at all, so that you are not obliged to. And if you register but you don't finish, then differently from the let's say your normal courses, if you register and don't finish, you will get no show in the study information system, which is a bad thing. But here, if you register and don't finish, nothing happens. Problems. Of course, I hope that you finish. Okay, now we are moving closer to the exam, but we are not yet very exactly at the exam. In order to support that you work throughout the semester, there are 2 interim tests that will take place. There will be 2 times. They will be via Moodle. We will agree the times separately. Since they are on Moodle, you don't need to be here. They do not take place during the class time because we don't want to waste class time for that. Oftentimes some kind of evening, 6 o'clock or something. Or I think we even had quite a wide range. Yeah, okay. It will be some hours on some day during which you will have a time slot where you can do the test. And each test gives you 10% of the final grade or 10% of the final mark, so that they do have influence on your final grade. The tests are without using any materials. And again, since you will be doing them in your dormitory or wherever you live, I have no way of checking whether you used any materials or not. So I will simply count that you are honest. There's also something called honesty declaration or something that you have to click and like acknowledge that you don't do any of those things that are said. And in order to do the tests well, then of course the obvious things to do are here. Yeah? Participate actively, ask always questions, do self-tests of the online course. And then the exam, it will be an oral exam. And we almost always have done it via the big blue button, like we are doing now, but then there will be just me and you here, and our videos will be, and so on and so forth. And I will give you the questions, and you will give answers, and you can make all kinds of schemes using these drawing tools and so on. Or alternatively, if you don't find it convenient, you can do on paper and show to the camera. If anybody really wants to be in the same room with me physically, we can also do that. But actually, via Big Blue Button is much easier logistically because I don't need to reserve the room. Yeah? It can also be some evening time when you're in your dormitory. And this also means that with each and every one of you, and there are quite many of you, we will have a separate exam. And one exam on average takes 1 hour. But one hour is like our contact time. For you, it will be longer because apart from that 1 hour, you will also have the calculation. Usually the way I do is the following. Suppose you have your exam time 3 o'clock on some day. From there, we discuss all the theoretical questions. Yeah? And then I will give you the practical exercise. And then we close the session. You will start working on the exercise on your own. Yeah? And usually I give you time until the next morning. Suppose the exam ended at 4 o'clock, then next morning, 9 o'clock, I would like to have the exam the calculation file. Calculation files are uploaded in the Moodle. I will explain all that when the time comes. Don't worry about technicalities at the moment. So you will have hours for doing those calculations, and if you have participated in classes and done the homework, then it should not really be very difficult or nothing really unexpected or very. And then the next day, at some point, we will do an additional short session where I simply explain what you did well, what you did not do so well, and I will announce you. I started doing oral exams during the COVID time. Previously, they were always written. And I realized how much fairer grading is possible with oral exams. I understand very much better whether you actually really understand or whether you simply have learned some nice sentences and now you are writing those nice sentences. So when I say the grading is much fairer, it does not automatically mean that the grade is higher, or also be lower. So that, let me stress again, I don't plan to teach you anything really sophisticated. These are mostly quite simple things. But those simple things have to be very clear. Very clear, without any hesitation. Very important. And when I grade the exam, I take, of course, into account whether the answers were right or wrong. But look here, also this, what this means. If I ask something and you say, yes, it's this. Okay. If I ask something, you say, I think that it's probably, I would say it's this. I think we all agree these are very different answers, even if both are correct. So if one person answers everything like a machine gun, so that I can hardly finish my question, the person already knows the answer. The other one thinks and tries to find words and so on. Then these people are not at the same level of knowledge. Clearly. So that, again, clarity and very, very clear understanding is. Also, the grade will be summed up by components. So 10% from one test, another 10% from another test, usually 40% from the theoretical answer and another 40% from the practical exercise. I'm not saying it will be exactly the same way, but usually this has been. But sometimes what can happen is that person has fairly good grades from some things, but then makes some mistakes which reveal that he or she doesn't really understand at all. So that if I see really serious mistakes, they can rule out A or B, even if some summing of some grade points sort of should be A. Suppose it's 91 point out of 100, which usually is A, but if within that there's some very serious mistake, I might decrease that to B. Yeah, and of course I already mentioned if some homework's not completed, grade will be. And this is, I think, my last. Yeah, perhaps still, let's say here is also something important. When you answer during the oral exam, the theory part, you are not allowed to use any material. You actually cannot use them very well because we are watching at each other. Yeah, you cannot go open the materials. And before the exam, I usually ask specifically to close all windows on PC, which might contain some electronic material. But during practical part of the exam, you are allowed to use any materials or any files on your laptop. Also, you are allowed to use Excel files of these practical classes that we did here. But in neither of the parts, you are allowed to do any communication with anybody else. So no Skype, no Messenger, no WhatsApp, no nothing. Yeah. So if you wish, you can use during exam even your friend's calculation files. But you have to ask your friends beforehand to give them to you. So whatever is during exam in your PC or openly on internet is allowed. Whatever you need to ask from somebody is forbidden. I hope that makes sense. Yeah, and this is all for the introduction. Any questions here? Could you take the no, the blue thing is sufficient. Yeah.
About the ruling out of A or B grade.
Yeah.
Does it happen during the oral test? Oral exam?
Yes. It happens very rarely, but there have been cases where tests are very, very good. Who knows why they are good, but okay, they are very good. Yeah. But then exam answer is in some places good, but then there's something that is absolutely off, which reveals that the person actually has grossly misunderstood something. So that does not happen every year that I have to use this kind of thing. It's rare. It's very rare.
And about
but it is possible.
Oral exam, does it happen before the interim test or after the interim?
After. By the time of the exam, all the interim tests are already done, yeah, and then all the homeworks you have hopefully done, and so on. So that at the end of the exam, when you have submitted your practical exercise, and when I have checked it, I will then the next day usually announce your grade. Which is also a good thing of oral exam. In written exam, I think you all have experienced that sometimes you have to wait for your grade for a long time. Teacher has not checked your exam answer yet, and next week still not checked. But with oral exam, it's very fast. And also I will give you very concrete feedback. Okay, here I decrease you 3 points, here you this mistake, I take 2 points away. And then you have immediately the possibility to object. Maybe I was unfair. No? And it's very, very rare that anybody objects. Because again, let's see, I explicitly explain where the points were lost. There's usually very little room for arguing. Yeah? If something was wrong, it was wrong. Yeah? There can only be argument that, okay, you took 4 points away, maybe you should have taken 3 points away. Okay, then we can discuss that, yes, but how big the penalty should be. But here I try to be like very similar to all of you. If there's some typical mistake from which I usually take 4 points away, then if you say, no, 4 is too many, you should take only 3 points away. I say, no. Because I have to treat all of you equally, yeah? and I've done the same with all the other students, and then I will do the same with you. No, I think it is quite fair. Again, as I said, it's very, I can think of one person who tried to object, but I think her score was something like, let's say 82, and I said B. The person wanted A. But you see, if it's 82, I have to be wrong by 8%, 8 points. It's not enough that, okay, instead of like taking 4 points away here, I take 3 points. That will make it 83, which is still B. So I have to be a lot off, which is not really right. You should not be too much afraid of this exam. I would say if you work hard and try to understand things, it usually plays out pretty well. Okay, any other question?
I have a question with the online course. In the end, if I don't register the materials that are listed there, get blocked or something, or like they're always available for everyone?
Yeah, it's slightly more sophisticated than that, but let's put it this way. Everything that is at this address, meaning all video lectures, all example calculation files, all self-tests, are available to anybody 24/7 without any registration. If you register, you will additionally get access to Moodle part of this course. And in Moodle, you have something which we call graded tests. Those are the tests that determine whether you pass the course or not and what grade you will get. So those you cannot access without registering. But those graded tests, of course, are also very useful in training for this particular. So that everything for self-training and learning is here without any registration, without anything. But if you want to get this one ECTS, you have to register. And then when you register, you will receive an email which explains how you access the Moodle part or the Moodle component. And there you find those tests which are graded and where also you have limited number of attempts. Here you have unlimited number of attempts. And in the homeworks of this hour course, you have unlimited number of attempts. But in this online measurement uncertainty course, you have limited number of attempts of graded tests. If you use up all the attempts, at least in one topic, you have failed. And you have to come back next year. And you can take the course again next year. The number of attempts, I think, ranges from 3 to 6, depending on the difficulty of the topic. I might be mistaken. I don't remember from the top of my head. Luis, did I answer you?
Yeah. And all the like the exams and the homeworks are totally different from the ones that we have already in this course. Or like
I didn't understand the question.
Like this is like a separate course from the ones that we're taking now.
Yes.
So the homework and the tests like
absolutely
totally different.
All different. Yes. I'm not saying totally. There are similarities here and there, but yes, it is completely separate course with completely separate grading, completely separate. And for passing this metrology and chemistry course, you don't need to take this one. It will not count in any way. It will not give you any extra points, but it will give you extra knowledge, and extra training opportunities to become better, so that you will be better in answering the questions of this course. Right, Tane?
Like, can we see the recorded classes later, or we have to watch them as?
Good point. Again, all the recorded lectures and things are available 24/7 and have been available for something like 10 years, I think, already, and are available this evening via this address. But these dates govern the time period when in Moodle the graded tests are open for you. So that during this time period, you have to do the graded tests if you wish to pass the course and get one ECTS grade. The course in Moodle is also broken down into weeks, and different weeks have topics and so on and so forth. But you are absolutely not obliged to follow those topics like that. In principle, you can go on 3rd of May and do on one day all the graded tests, and you are done. Yeah, so you don't need to follow any timeline. Simply, the tests, the graded tests, will become available on March 25 and will close on May 7. In that time frame, you have to do all the graded tests. Then you can get this one ECTS point and can pass this online. Did I answer? No, it's not. this course also has some letter grade. It's not only pass or fail, because in this course, differently from our homeworks, you are not required to get 100%. The threshold for a positive grade here is that every test has to be passed at least at 50% level. Or was it 51? It may be at more than 50%. Again, I don't remember so well from the top. But in any case, here it is possible to get A and B and C, etc. But I think it's very difficult to get E for this course, because if at least one of the graded tests is below 50, and you have exhausted all attempts, you have automatically failed. Whatever the grades of the other tests are, they don't help. So this one, the grading here is somewhat different from what we have here. Did I explain? In this connection, let me also tell something about this. These interim tests. Yeah? Here, you cannot fail in the sense that there's no threshold. Even if you get 0 for a test, nobody has ever got 0. But even if you get 0, you can still go to exam, you simply lose 10 points. So these interim tests, in the sense, cannot be failed. Whatever is your number of points or a grade from the interim test, it's considered passed. You simply lose later on some part of your exam grade. This is also the reason why you cannot retake those tests. You have only one attempt. All right. So, any other questions? If not, then we go into the real topics, and I now briefly show you this here. This is our list of topics of this course. And as you see, this course is in broad terms composed of 4 different parts. Part number 1 is measurement result, measurement uncertainty. So it's a very general one. A large part of it is about measurement uncertainty, but it also gives quite a bit of additional analytical chemistry knowledge, which I promise that you will get. We will go from the very beginning. We will explain all the main terms and conventions and things and so on and so on. Yeah. And we also look at 2 different measurement uncertainty evaluation approaches, the so-called ISO-GAM modeling and the so-called NORTEST approach. Second part is reference materials and interlaboratory comparisons. These are 2 large tools for metrology in chemistry. 2 large tools. Reference materials, as you know, are some objects where there's analyte inside, and then you know how much is inside. Yeah, this is in very, very simplistic terms, but this is essentially what it is. And interlaboratory comparison, of course, is something that many labs analyze the same type of sample. Again, those of you who were in the winter school, you have just done one interlaboratory comparison, so you have some idea what it is. Part 3 is about validation, method validation, and then the quality control or control chart. And then part 4 is the smallest. Yeah, it only has 1, but very important concept, which is traceability, which I will explain later. And in a way, all this that I will be teaching you, it has one single aim. If we want to in some way put into one sentence what is the aim of this course, is how to make that your analysis results are good. How to achieve that your analysis results are right or are not wrong. Let's put it very, very simplistic. all these approaches are meant to support that aim, that your analysis results are okay. And now let us start with measurement uncertainty and measurement, etc., and then some very, very basic. So I perhaps don't need to explain what measurement is. Yeah, it's the process of experimentally obtaining one or more quantity values that can be reasonably attributed to a quantity. So essentially, measurement is comparing your object or your, let's say, sample properties to some reference object properties. And we will come to that later on via calibrations. Yeah. And metrology or measurement science is a science of measurement. And whenever we look at measurements, the quantity that we intend to measure is called measurand. So measurand can be either the mass of some physical object, for example, can be percentage of nickel in steel, and can be the content of essentially any molecule, any element in any kind of object or in any sample. So let us also make it clear that lead is not the measurand, yeah? But content of lead in a sample is a measurand. Lead is the analyte, it's the species that we are. And here comes the next set of terms, which again I think are all known to you already. Analyte is the chemical species or chemical entity that we need to determine. So all these nickel, cholesterol, lead, dietary fiber, glucose, saccharose, some pesticide, etc., all those can be analytes. Then, when we analyze some objects, which are also sometimes called sampling targets, then typically we don't bring the whole object to the lab, because the whole object can be the whole lake, or 100 tons of some material, in some storehouse. We will take a sample from this object that we bring to the lab and make the analysis. And of course, as you have learned with Professor Coit, and some of you with me in previous courses, sample has to be representative in order to be able to characterize the whole object. And then matrix is the sum of all components in the sample. Sometimes people say that matrix is everything else in the sample than the analyte. And this is correct if analyte level in your sample is very low. So if you do some analysis of lead in drinking water or pesticide in food, then this is very okay. You can say that the drinking water sample contains lead, which is your analyte, and everything else is the matrix. But if your analyte is one of the main components, for example, if you determine fat in cheese, cheese can have 15, maybe 20% of fat, then that analyte, that fat, has to be also counted into matrix. The reasoning is that whichever molecules can come in contact with your analyte molecules or ions should be counted into matrix. If it's lead in drinking water, there are so few lead ions, they almost never meet each other. So two lead ions never meet. So lead can be left out of matrix. But two fat molecules in cheese can easily be next to each other, so that if determining fat in cheese, the fat itself has to be also part of the. Now, the next thing, if we speak about quantitative analysis, should bring in measurement value, measurement error, and measurement uncertainty, and try to make sense of these topics, concepts. But before I do that, maybe any questions? Yeah, could you pass the microphone?
Okay, I just want to clarify regarding 1TP. We cannot consider pH, turbidity, or let's say conductivity as an analyte. Is it right or wrong?
Yes, they are not analytes. Let's leave pH out for a moment, because pH is a very tricky thing. But conductivity and turbidity, you can call them physical measurements. Although chemical analysis labs do them all the time, yeah, and many people don't really think about that, and conductivity actually comes via chemical species because it's ions who do conductivity. But in conductivity and turbidity, per se, these are not analytes. But if you do sulfate determination by turbidity measurements, and there are some standard methods for sulfate determination which involve precipitation, and then precipitate forms some haze, and you measure turbidity, then turbidity is the physical quantity that you measure, but sulfate ion is your analyte. Did I manage to explain? Yeah. But sometimes, suppose now that you analyze natural water. Natural water has a lot of parameters, yeah, that people monitor, yeah, environmental chemists. Turbidity is one of those. But in that kind of measurement, they don't try to assign turbidity to any chemical species. They measure turbidity just per se, yeah, just turbidity. Then we can say there's no analyte. It is just a physical parameter which shows how well light can pass through. You asked a very interesting question, by the way. Yeah, it is. It can be difficult, yeah, sometimes. Most of the time, if we speak about chemical analysis, we do have analyte and matrix and so on. For example, if I can bring in one more thing, for example, in industrial process control, oftentimes people monitor some spectral features which they do not rigorously assign to any specific compound. That is also still considered chemical analysis, because it enables, yeah, taking some decisions, yeah, that okay, the synthesis has probably ended, yeah, because these spectral features don't change anymore. But it's not really clear always to what exactly those spectral feature changes actually are. So yes, it can be difficult. And I specifically wanted to leave out pH. In the case of pH, it is the hydrogen ion that can be considered the analyte. But it's more tricky than that. It's not, pH is not really related directly to hydrogen ion concentration, but to activity. And the activity coefficient that is involved there is a very tricky and then strange thing. I could give a 2-hour lecture on this topic if you wish, but we don't do it here. I think I would recommend we leave pH out of this. pH is a very strange measurement, although it's possibly the most common chemical measurement. But from measurement science point of view, it's a very, very strange thing because of these properties. Luckily, most of the approaches that we have in this course also can handle pH measurement, so that all those control charts and traceability, all those are nicely applicable to pH. I see there's a question from Haider. I didn't get the part where you explained about that fat as analyte. Okay. Haider, what I was trying to say is, if your analyte is a macro component or major component in the sample, then it is both analyte and part of the matrix at the same time. But if it is a minor component, like lead in drinking water, pesticide in some vegetable or fruit, etc., then you can say that matrix is everything else in the sample except the analyte. Did it become clearer now?
Yeah, it is clear, but you told that the fat in the, let's suppose in cheese, it makes contacts with other parts of the cheese. So does it make it the part of the matrix because of that?
What I was trying to say was fat molecules in cheese get in contact with each other because there are so many of them. And this is the reason why they have to be counted as matrix. Pesticide molecules in orange are so few that they never see each other. They are in contact essentially only with all kinds of orange molecules. There's no such thing as orange molecules, but it's the sugars and acids and water molecules, etc. Yeah? So that in pesticide determination in orange, you do not need to count the pesticide as part of the matrix because the pesticide molecules are almost never in contact with each other.
Okay.
Was it better?
Yeah, it's clear now.
Good. All right, but let's now try to understand this scheme. This tries to explain the very basics of what we do in measuring something and what those terms that are in this title of this slide, what those terms actually mean. So whenever we make a measurement, our aim is to catch or to know, to learn what is the true value of the measure. So that again, if it's some water sample, we want to have lead content. So how many millimoles or milligrams of lead is in there? And if we think of it, then yes, if you have a glass of water, there's a finite number of lead ions in it. Yeah, so there is some kind of true value somewhere. Huh? So this true value is what we want to measure, what we want to achieve. Unfortunately, all our measurements are affected by errors, and errors shift our measurement result away from the true value, so that our measurement result is not really the same as the true value. And the difference between these two is called error. Can be expressed like this: measured value minus the true. But now, in almost all cases, the true value will never be known for us. We actually don't have a way of knowing, of learning how many lead atoms are in this glass of water. I don't have it in my hand, but we can imagine it. It is a finite number of atoms, but how many we don't really know. And we have no way of counting those atoms. So that we also do not know what the error will be. And as true value is in a way an abstract concept, we have no way of knowing what it is. Error is therefore also an abstract concept, because if we would know the error and our measured value, we would be able to easily calculate the true value from this equation. Yeah? So that neither the true value nor the error are not known for us. And this also means that we cannot evaluate the quality of our measurement result by error, because we don't know what the error is. And instead, what people are doing, they try to define some kind of range around the measured value, this range. So they define this range around the measurement value, within which they have the reason to expect that the true value is inside with a high probability. And that range is called uncertainty range. So uncertainty range is a range around your measured value that you obtain from your measurement, which you have calculated in such a way that it would contain the true value with high probability. This is the idea of measurement uncertainty. It defines some range within which somewhere is the true value. We don't know where it is, but we have calculated uncertainty in such a way that true value is there with high probability. We also cannot get 100% probability. I'll come to that in the probably next lecture. Why not 100% probability? Oftentimes it's like 95% probability, maybe 68% probability or something. Who thinks that understood what I just explained? Okay. People on the internet, please raise your hand if you understood. Okay, some people. Okay. Now, some people did not raise hand. Then this is the right moment now to ask, because this is a pretty important thing. This kind of graph, I expect you to be able to draw during the exam and explain. Then let's look here. Here is now one thing for initiating discussion. What are the main differences between error and uncertainty? What do you think? Claire, please.
So my point was that the error corresponds or is assigned to, in some way, to a true value that we will never be able to figure out. But uncertainty as a way to, well, estimating how close can we get to that true value with our measurement, whilst maintaining the uncertainty range as small as possible and maintaining the probability that the true value will land in that zone as high as possible.
Okay, yeah, you made several good points, actually. So first of all, yes, error has a sign. And error is the difference between something and something. Uncertainty does not have a sign. And uncertainty cannot be interpreted as difference between something and something. Uncertainty can only be interpreted as width of the range or as the extent of doubt. The wider the range, the more we doubt about how good our measurement result is. Okay. Now, Golam, you wanted to say something.
Error just falls within the range of the uncertainty, and while uncertainty explains the entire range.
We cannot say uncertainty explains. But yes, uncertainty tries to cover the range of possible errors. Let's put it this way. If uncertainty is well evaluated, realistically evaluated, then all the errors will still remain within this range with high probability, meaning all the true value will be somewhere here, but not really outside here, or will be outside here with very low probability. So yes, uncertainty in a way encompasses or embraces the error that is. Anybody else, any thoughts? Haider, what you say, uncertainty is a range, error is a value, is also pretty good, yes? I would say, to put it even like more exactly, error is a difference, but uncertainty is just a range. Anything else, anybody?
I was thinking like, how can we decide which is the best width for our uncertainty range? Because I mean, like if we make the range with a bigger width, so the confidence that we have that the true values within our range is gonna be higher. But if we have like a really big width in our uncertainty range, then as you said, like the measurement becomes like doubtful. So it's like I don't know how to balance those.
How to evaluate uncertainty is a big part of this, our course. So by the end of the course, you will probably know. But let me just say that you guessed very correctly a big issue that there is. In principle, we can always say, no, we are not sure in our measurement. It can still be wrong. And you put this wide uncertainty range. Then your measurement result becomes useless. Yeah. And if you put the uncertainty too narrow, then it might be underestimated, so that the true value might be outside of it with quite high probability. And how to find balance between these is to a large extent the part of this course. Yeah? The approaches for measurement uncertainty evaluation that I'm going to teach you do exactly that, enable you to get realistic uncertainty estimates. Did I manage to answer? Anything else, anybody? Yeah. There is measurement without uncertainty. How many pens am I holding in my hand? 3. Counting of small number of objects can be done without uncertainty. But I'm stressing small number of objects. If it's 30,000 pens that I have here, 30,000 pens, that can be counted. Might have uncertainty if you start counting them by hand. This is pretty much the only example that I can give you of a measurement without uncertainty. And primary standards also have uncertainty. There was, until recently, what was it now? 2020 or 2019, the mass ethanol, or the reference of mass, this platinum iridium cylinder, yeah, in France, in Paris, was an object with a mass of exactly 1 kilogram without uncertainty. But thereafter, mass measurement was completely redefined, so that object now has uncertainty. And right now on planet Earth, there is no such object with mass without uncertainty. Everything has uncertainty. Also, those primary realizations of measurement units, they are some measurement systems. I will briefly, a little bit touch upon them when we get to traceability part at the very end of the course. they enable realization of the units like mass, frequency, time, etc., with very low uncertainty, but those uncertainties are not. Almost everything has uncertainty. Okay, we stop here. We are already slightly over time, but we continue next time, which will be tomorrow, by the way. Yeah, next time we will continue here. And I want to bring in one more aspect, that sometimes this error can have a very good estimate, and we can have a very good estimate of the true value and what that means and how that might be helpful. So that everything we explain now is fundamentally exactly as it is in this slide, but next time we will slightly widen this view of this whole. But for today, yeah, thank you, and we close.